We've talked about how devices can be connected to one another either via a wired or wireless connection, so now let's talk about how they can communicate once they're connected and how switches work to facilitate that communication. Now, while this lesson will focus on what's called a broadcast domain, we're also going to introduce three different types of traffic since these terms will help us understand what broadcast domains are and how they work. The first one we're going to talk about is called unicast traffic. The second is multicast traffic. And the third is broadcast traffic. Starting with unicast traffic, this type of traffic is directed to a single destination host. For example, here the sender is sending one packet to receiver A, but no one else receives that packet. We also have multicast traffic, and this type of traffic is directed to multiple interested hosts. And you can think of this kind of like a radio station, where in order to listen to a radio station, you need to tune in, if you're interested, to the proper frequency. And this essentially is what happens with multicast traffic. The other type of traffic is broadcast traffic, and this type of traffic is directed to all of the hosts. Regardless of whether the hosts are interested or not, it doesn't matter. They all receive it. But unlike switches, routers do not forward broadcast traffic. As you can see, the router's interface that connects to the switch receives the broadcast, but it does not forward it to its other interfaces like the switch does. A switch will forward broadcast traffic out to all of its interfaces except for the one where it receives the packet from, which makes sense. So now we're ready to talk about broadcast domains. A broadcast domain is a group of devices that send and receive traffic from and to each other. That means you can have a network with more than one broadcast domain. And routers are used to divide these broadcast domains by assigning each of their interfaces to a different network segment. And as said before, we will talk about routers later, but for now, let's focus on the broadcast domains because they help us understand how switches work. So let's go ahead and see how. Like we discussed before, switches use MAC addresses to send and receive information. And to send and receive that information, you need both a source and a destination. Or again, it's called the source MAC and a destination MAC. But to keep track of all of this, switches create what is known as a MAC address table. So let's see how this table gets created. For these examples, we have oversimplified how a MAC address is represented. But let's imagine this network topology. Here you have three different computers that are connected in the same network via the same switch. And let's say that computer 1, which has a MAC address of 1.1.1, needs to send a packet to computer 2, which has a MAC address of 2.2.2. So we have our source MAC of 111 and our destination MAC as 222. So the switch receives this packet on port number 1. Then it says, hey, I have MAC address 111 connecting on port 1, so I'll add it to my MAC address table at that information. And this packet has a destination of 222, but I don't know where 222 is, so I'll send this out to everybody in my network. And this is where the broadcast domains enter the game. All the devices connected to the switch are in the same broadcast domain and receive the packet. So computer 3 receives the packet and says, hey, this has a destination of 222, so this is not for me. I'll just go ahead and discard it. So computer 2 receives it and it says, yeah, this has a destination of 222, so this is for me. So I'll go ahead and reply. And then the switch receives the packet on port 2 from computer 2. Now the switch says, I have MAC address 222 connected on port 2. I'll go ahead and add it to my MAC address table. Also, this has a source of 222 and a destination of 111, but where is 111? Well, I don't need to ask everybody because I already have it in my MAC address table and it's connected to port number 1. As you can see, we can use broadcast at the beginning of the connections when the switch doesn't know where each MAC is connected. And once the switch knows which MAC is connected to which port, then the packet is sent directly, which optimizes performance. So let's go ahead and take a look at a slightly more complex example. Let's use this topology that now uses two separate switches. So this time we have 4 total computers, 2 connected to each different switch. So just like before, computer 1 sends a packet. Switch 1 learns the MAC 111 is connected to port 1 and adds it to its MAC address table. The switch sees that the destination is 222, but this MAC address is not in its MAC address table, and so it sends a broadcast asking everyone, and in this case, it sends it out through port number 2 and port number 5. The packet hits switch number 2 on its own port number 5, sees that the destination is 222, but the switch number 2 doesn't know where that MAC address is, so it asks everybody as well. But switch 2 has now learned that the MAC 111 address can be reached through its port number 5, so it adds that to its table. Even if it's not directly connected, it still now knows that it can reach it via this port. Computer 3 and 4 receive the packet, but discard it since they're not the destination. But at the same time, computer 2 has received the packet as well, and it recognizes that it's the correct destination, so it replies, hitting switch 1 on port number 2. Switch 1 now learns that MAC 222 is on port number 2, and switch 1 sees that the destination is 111, which is already in its MAC address table, so it sends it out using port number 1. Now let's say that computer number 3 also wants to send a packet to computer number 2. The packet hits switch number 2 on port 1 and adds the MAC address 333 to its MAC address table. Switch 2 sees that the destination is 222, but this is not yet in its MAC address table, so it asks everybody. Now switch 1 learns that 333 can be reached using port number 5, and then computer 444 discards the packet. The packet is in switch number 1 and sees that the destination is 222, which is already in its MAC address table, so it sends the packet out to port number 2 without asking port number 1, and then computer 2 replies. Switch 1 sees that the destination is 333, which is already in its table, and sends the packet out to port number 5, which hits switch number 2, and now switch number 2 learns that 222 can be reached using port 5, the destination is 333, which is already in the table, and so the packet is sent out to port number 1. Now, of course, all of this happens tremendously fast. It took us a while to get through this verbally and to show it graphically as well, but when the computers are doing it, it's at a blink of an eye. Actually, as we talked about, it's even faster than a blink of an eye, so it's really quite impressive. But that's essentially how switches learn where to find destinations and sources, and that's how MAC addresses are used to deliver packets. So we're now ready to move on to the next layer. Go ahead and complete this lesson, and I'll see you in the next.